Okay, more work for social ontology. I think you will know what I mean by that by the end of this. So let's just get right into it. We can think of this project or the proposal that I'm making under the topics of metasocial ontology and meta-metaphysics. So I'll be talking about social ontology as a whole, and I'll be talking about metaphysics as a whole. So that's where it's located. I'm going to be talking about both of those fields and the relation between the two. So it's under those. And one way to think about the relation between so-called traditional metaphysics, whatever that is, and social ontology is applying the tools of traditional metaphysics to social ontology. So one example, maybe things like dollar bills and book clubs have essential and accidental properties. So in this example, we are taking ideas from traditional metaphysics, whatever that is, and applying it to objects in the social world like dollar bills, book clubs, other social groups. All right, so that's one way that that could go. And then we see an actual example in Brian Epstein's book, The Ant Trap. That's a work that you'll see I'll be heavily relying on in a couple ways, but this is an actual example. So he takes some ideas from modal metaphysics and possible world semantics and then applies that to his model for social ontology in the social world. So a quote from him: "A frame is a structure containing this universe, that is, a set of possible worlds in which the grounding conditions for social facts are fixed in a particular way." So again, you see there's some ideas from modal metaphysics, and it's applying to the social world in this case. And I want to ask the question, what if we thought about the relation between these two fields in a different way? What if we took some of the tools from social ontology and applied them to some traditional ideas, puzzles in traditional metaphysics, whatever that is again? So here's the thesis that I want to propose. Given the dependence of many features of objects on social agents, the social world may be much bigger than we thought. So I want to show this during this presentation and with this paper. Okay, but first, the structure of the paper. Here's the way it's going to go. I'm going to talk about some agent-dependent features, and those will include boundaries, number, and kind membership. So I'm just going to briefly mention those agent-dependent features. I'm not going to make a strong case for any of them. I'm going to be relying on other works that have done that, but I will mention those as agent-dependent features. So that's the first part. Second part, I'm going to mention a couple traditional metaphysical puzzles. So again, this is applying some of the tools from social ontology to traditional metaphysical ideas or puzzles. First one is the problem of the many. I'm going to be addressing that. And the second one is the problem of material constitution. So that's the way that the paper is going to go. Social objects. I need to say a little bit about what I mean by social objects. I'm going to be characterizing social objects in a pretty liberal way. And so here's what I mean by social object. A social object for me is an object that exhibits at least some features that are social, in other words, agent dependent. All right, so I have in mind here also non-anthropocentric contexts, like tools in nature. So things like nests, things like hammers. You see from the picture there on the slide that a monkey is using a rock. Maybe we could call that a hammer. To get some food, get a nut out of its shell. So those kinds of things in non-anthropocentric contexts, I think, are included as social objects. So it's pretty expansive. I'm not going to go into that context in particular, but I note it just so that you understand the sort of the scope that I'm talking about when I mention social objects. I also think it's not necessary that all of an object's features are agent dependent for it to be a social object. Only some of an object's features can be agent dependent for it to be a social object in the sense that I'm talking about. And so given all this, there's a sense in which almost any object could be a social object. I grant that. So if we think about objects in nature, just sort of natural objects, things like the rock that you see there, that could be a social object. There are vines, with the animals swinging from them. Those sorts of natural tools, I think, could also be social objects as well. Again, I'm not going to go into that aspect of the scope of social ontology, but I mention it, again, just so you know what I have in mind. And then I should state here at the outset, when I'm giving conditions, I'm going to be assuming unrestricted composition, committing to that. You'll see why, but unrestricted composition is given any x and y. There's a unique mereological fusion of x and y. And again, you'll see why I'm mentioning this a little later. So let me get into a few of these agent-dependent features of objects that I was talking about. The first one that I want to mention is boundaries. And here I am relying on Varzy's 2011 paper called Boundaries, Conventions, and Realism. So again, I'm just mentioning this. I'm not going to defend this. I don't have enough time to really defend each of these features fully, but relying on his article to do that. So in his article, just to take one example, he uses the arbitrariness of boundaries, that an object's boundaries are largely up to us, to argue for a realist conventionalism that's applied not only to artifacts but to natural objects as well. All right, so I'm just going to lay out a couple quotes that are representative for how his argument goes and how the article goes. And so the first one, let me just read this. He says in there, boundaries play a central role at any level of representation or organization of the world, and so does the relevant artificial-natural distinction, artificial boundaries, natural boundaries. We think of a boundary every time we think of an object as something separated from or distinct within its surroundings. So it's a significant feature of objects, boundaries. There is a boundary, artificial, separating my part of this shared desk from my colleagues, for example, my head from the rest of my body, or the sirloin from the rump on a butcher's chart. There's a boundary that's natural, demarcating the interior of an apple from its exterior, the hole from a donut, or shadow from light. So that comes from one of the first parts of the paper there. And you can see I included a picture of a shoreline just to give you an idea of another boundary that's mentioned in the article as well. And then this second quote, I'll read this again. He says later on closer look, the spatial boundaries of common material bodies involve the same degree of arbitrariness as those of any mathematical graph smoothed out of scattered and inexact data. The same degree of idealization as a drawing obtained by, quote, connecting the dots. It makes no sense to inquire about the owners of those boundaries, or rather it only makes sense insofar as we recognize their ephemeral status as fiat demarcations, that's important, that exist, and here's key, in virtue of our cognitive acts, but that are not genuinely present in the autonomous, which is to say mind-independent physical world. So here he says, again, just kind of summarizing, these are fiat demarcations, even on natural objects. They're in virtue or maybe grounded by our cognitive acts, agents in some way, but that they're not genuinely present in the autonomous or mind-independent world. All right, so those are some of the reasons why boundaries are, at least in some sense, agent-dependent. All right. So the next aspect that I want to talk about that is agent-dependent is number. And we can ask, what fact or facts ground the fact that an object is one or many? And the answer that a lot of philosophers have given is kind membership. That grounds the fact or facts that an object is one or many. So the number or count of an object is relative to kinds or sortals. And you can see this in a number of figures. This was Frege's philosophy of counting. This is brought up in Berto and Carrara's 2009 article, To Exist and to Count. So we could ask the question, again, based on this, is the object that we see here in this picture, the cans, the six, one object or many? And we can answer it this way. The reason that the one six-pack that we see in front of us, that picture, the reason one six-pack six-pack of 6 cans is 1 is because the 6 and the 1 are relative to different kinds of objects. 6 objects fall under the kind can. I'll represent kinds with all caps in this case. 6 objects fall under the kind can, and 1 object falls under the kind 6-pack. So we have one thing, we have many things, and those things are relative to the kinds. So that's number, again, very briefly, just to get it on the table. And if we're talking about kinds, I want to talk a little bit about kind membership. And to do so, as I mentioned previously, I'm going to be employing Brian Epstein's grounding and anchoring model for kinds. I don't want to rehearse his entire model for social ontology. Given the context of this conference, that it's a conference on social ontology, I'm going to be relying a little bit on background knowledge for that. If you have questions, we can get into that in the Q&A. But just a quote to sort of demonstrate what I'm talking about from his book. He says, facts about people or agents may be involved in anchoring. For instance, the anchors may be the collective intentions of people in the community. So first, facts about agents anchor or set up the rules for facts about kind membership. Those rules are set up and chosen within some sort of social context. So, for example, facts about a dollar bill stand in an anchoring relation to the facts about conventions or rules that give the conditions for something to fall under the kind dollar bill. Namely, the fact that the dollar bill was issued by the Bureau of Engraving and Printing, and some other facts as well. So that's one example illustrating how that model is set up. And then further, the model here is going to be anti-individualist, really again relying on the anti-individualist theme of a lot of Epstein's work in his model for social ontology. So facts about groups like the US Supreme Court, for example, cannot be reduced to facts about the individuals that compose it. That's what we mean by anti-individualist or anti-individualism. So to just one more comment on that, if you think about the Supreme Court, for example, that's a social object that has existed for decades, centuries even, and there are facts about the Supreme Court, the individuals of which have changed over time completely in many cases, in pretty much all the cases. So I'm going to be including anti-individualism in the case that I'm making for kind membership and its agent-dependent features. All right, so let's talk about how I'm going to apply these agent-dependent features to a couple of the metaphysical puzzles that I mentioned. And I want to make 2 specific qualifications. To summarize, the boundaries of an object, the count of an object, and the membership of an object into some kind are all features of objects that are at least partially up to us as social beings. At least, that's key, at least partially up to us as social beings. And this, I say, creates a social profile for many ordinary objects. And here are the 2 qualifications. The first one, I'm not arguing that some object is either wholly or completely agent-dependent, or, on the other hand, wholly independent. I have only wanted to show how some significant features of objects, like the ones I just mentioned, how those are agent-dependent. And then secondly, I'm not arguing that the agent dependence in question is completely unrestricted. And so I want to make room for some restrictions on placing the boundaries and the count and those sorts of things. And so it's not as if we can just make objects whatever we want them to be. What I want to do is just highlight which features are agent dependent, at least partially in some sense. That's what I want to focus on as I apply some of the things that we've been talking about. Okay, so getting into the second part now, talking about the problem of the many. This problem, the problem of the many, was articulated in Peter Unger's widely known article, The Problem of the Many, appropriately titled. And so here's one way to illustrate the problem. It's going to be a little different from the way that Unger articulates it in the example that I give. But consider this tree that you see that's outside my window. There's a picture of the actual tree outside my window as I was writing the paper. So consider this object, it's a tree, and we could ask, how many trees are in this picture? And so to answer that question, we can start with some familiar story about the tree's composition. There's a large cardinality of microphysical particles that compose the tree, and we're going to call that tree T1. The picture that you see, the tree that you see in front of you in the picture is going to be T1. Okay. So if we take that tree, if one of those particles from that tree, and let's call that particle P1, is removed from the tree, and if we're also assuming unrestricted composition, which I am in this case, then we have a different object, T2, composed of a different number of particles. And so T2 is going to be T1, that original tree, minus one particle, P1. All right, so there we have another tree. But then if a different particle, P2, let's say, is removed, we would have yet another object. Call that tree T3. And you can see where this is going, right? Many trees are involved here. We could keep numbering different trees based on which particles we're removing. So there are at least two ways that T1, the original tree, could lose a particle. It could lose a particle over time, or it could lose a particle at a single time by considering a different, equally legitimate boundary that doesn't include P1, let's say, that particle. And so there are millions of combinations of particles considered from this fixed set of particles that compose T1, that original tree, at one time. And all combinations fulfill the conditions for those objects to be members of the kind tree. All of these are trees in some sense. So here we have a dilemma, and this is the problem of the many. Common sense tells us that there is one tree here. But the problem of the many is that there are either no trees here, and that's nihilism, so I don't want to deal with that horn of the dilemma, or we have millions of trees here, again, against common sense. Common sense tells us that there's just one tree. So again, T1, T2, and T3, and on and on and on, all fulfill the conditions for being members of the kind tree. And that's where we get all these millions of trees, given the particles. Okay. So given all that, here's another way to articulate the problem of the many from a recent article. I thought this was a good articulation of the problem from Openshaw. He says the kinds or sortals under which ordinary objects fall carve microphysical reality in a coarse-grained and imprecise way. Take Tibbles, a typical cat. There you see a picture of maybe Tibbles. Almost coincident with any microphysically precise specification of the lump of which Tibbles is made is a distinct lump which resembles the first extremely closely in relevant respects. So you see here the analogy with the cat Tibbles and the tree that we were talking about. Perhaps it is exactly the same, but for one particle. So you could have C1 and C2 in this case, cat 1, cat 2. Question, in virtue of what does this first lump of matter make up a cat and the second not, if it doesn't? So that the problem of the many can be clarified at the level of kind or sortal, and hence number, as we saw before, that those two things are intimately related. And our social conditions for, or our rules for what falls under the kind tree or the kind cat are too coarse-grained, as he says, and imprecise to distinguish microphysical differences between objects. So when counting differently located macrophysical objects, let's say, like Tibbles on the mat or another cat Felix in the backyard located somewhere else, this imprecision obviously isn't a problem for the way that we set up kinds. The problem is that there's a common sense notion that some tree or cat that we're looking at is one in number, and that we're not looking at millions of trees or cats. But, I say, if we have any role to play in the conditions for some kinds, if that's agent dependent in some way, then we could be more precise in distinguishing conditions for the kind we have in mind when we're talking about this problem, these objects. There are actually two kinds of trees that are referred to in the way the problem of the many is set up. When we say that there are millions of trees in one location, like the way the problem is set up, we are not counting millions of trees in one location, none of which overlap with one another. That's not what we're saying. There are, of course, millions of combinations of particles, and all those millions of combinations fall under the kind tree. So which kind of tree are we talking about? Are we talking about overlapping tree, just to make it short, or non-overlapping tree, right? A tree where the parts overlap, or a tree where none of the parts overlap? In our common sense usage of the word tree, we typically have in mind a particular kind of object when we count trees, non-overlapping trees. So we say one tree, two tree, trees. Typically, we're talking about non-overlapping trees. Part of the problem of the many trades on the macrophysical imprecision that we saw here when we're talking about the kind tree, for example, and whether in some contexts we want the kind to include overlapping trees or not. In contexts where we need to be more specific on the overlapping question, perhaps we refer specifically to the kind non-overlapping tree or overlapping tree, depending on the context. So the number of objects that fall under the kind tree is in many ways agent dependent and up to us as social beings. For the non-nihilist horn of this dilemma of the problem of the many, in virtue of what we can ask is some combination of particles a tree? Well, it's partially in virtue of some facts about social agents. So that, in that sense, I think some of the ideas from social ontology in their reference to kinds and the number, etc., clarify what the problem of the many is. So that's the first problem. Second problem, I want to talk briefly about the problem of material constitution. You see here on the slide, there's a lump and then there's a statue, so that's what I'll be talking about. And in Epstein's book, The Ant-Trap, he explicitly mentions actually the classic puzzle of the lump and the statue from Gibbard's 1975 article, Contingent Identity, where in that article, the lump of clay, for example, has the property of being able to survive being crushed. That's one property the lump has, while the statue has the property of being destroyed if crushed. So these two objects have different properties, and that's at least part of the way that the problem is set up. So here's some constitution questions that we can ask, questions about constitution. One question, how can two objects, the lump and the statue, coincide yet not be identical or numerically one? That's one question that we could ask. Do the lump and statue stand in the constitution relation? It's another question. And there are advantages and disadvantages to how one answers these questions. Some people assume that they are identical. There are a number of views that I won't rehearse here. But I want to focus on another way to tackle this puzzle or this problem of material constitution. I want to go further upstream from this problem of conflicting kinds for some object or objects, depending on how you see this problem. I want to ask, does some object in question fall under the kind lump? Does the object in question fall under the kind statue? Does it fall under both kinds, or does it fall under neither kind? That's another way to ask the questions related to material constitution. Epstein's model in The Ant-Trap and other articles, obviously, focuses mostly on social objects and social groups, but it does recognize in a few places conditions for an ordinary object, and we could call that a group of particles, let's say, recognizes conditions for that ordinary object to fall under a particular kind. At least some facts about those conditions depend on facts about agents. We see that in the way that the grounding and anchoring relations are set up. And I think a benefit of Epstein's anti-individualist model is the way that it can account for objects falling under many different kinds simultaneously. So for example, all the members of the Houston Astros may also be members of the Houston Book Club, to take a silly example. And in the same way, analogously, there are conditions, for example, for when an object falls under the kind lump, whatever those conditions are. I don't need to claim that at this point, what they are. Maybe the fact that a lump is amorphous and shapeless, that might be one of the conditions for falling under the kind lump. And there are also conditions for when an object falls under the kind statue, whatever those are. Maybe the fact that the statue was made to resemble some other object, like in this case, if the cat statue here was made to resemble Tibble's, to bring it full circle. The fact that it has some discernible, discrete parts. Maybe those are conditions for some object to fall under statue, among many other conditions as well. But in contrast to this constituting relation that we've talked about, and that's talked about in the Ant-Trap and elsewhere, I want to apply the model from social ontology that we've been talking about to composite objects that are groups of particles that we could say. And I want to do this to clarify the problem of object coincidence that's going on in the problem of material constitution. So instead of the fact that the Supreme Court exists, facts here are represented by italics and bold. I want to replace that fact with the fact that the statue exists. All right. So in this case, when we're talking about the fact that the statue exists, not all facts about the statue are grounded by facts about all the individual particles that compose the statue, just like in the Supreme Court case. The statue may lose or gain some number of particles, and at some point they may be arranged differently and not fall under the kind statue. They may fall under the kind lump in some cases, and they may fall under those kinds in part because of the social conditions we give for an object to fall under those kinds. And then further, just like in the case of the Supreme Court, I'm assuming anti-individualism about composite objects and ordinary objects. Again, not all facts about the statue or the lump or other material objects are grounded by facts about the individual members. And facts about the persistence of the statue, right, over time are not fully grounded by facts about all the individual members as well. And again, like I said, Brian Epstein touches briefly on some of these similarities and differences between groups and ordinary objects. So I'm giving full credit. A lot of these ideas have come from some of the things that he mentions, given the ideas that are similar from social ontology and then ordinary object metaphysics and ontology. And he says this in one place, quote, "Like groups, many ordinary objects can persist even through changes in their composition. Parts of a ship, for example, can be replaced without destroying the ship, and parts of a human body can be replaced without destroying the body." He also mentions in one place, at least in the Antrap, ordinary natural science objects like a rock. So I don't want to get into that, but the same principles apply. Just want to recognize that that's mentioned elsewhere as well. So just again, as the Supreme Court can persist through many changes in its composition, so the ship of Theseus, which is alluded to here, some ordinary composite group of particles, those objects can persist through many changes in their composition as well. So just like a social group is made up of individual people, but we have anti-individualism in terms of the facts about them, so it goes for composite objects and their particles that make up those as well. The conditions that we give for something to be that one object numerically, its identity conditions, will be at least in part up to us. I don't have enough time here to get into identity, but I think there is some good work that is to be seen out there regarding identity and how that agent-dependent feature, in some sense, can be explored. So identity conditions, and again, I'm just hinting at this point, identity conditions, conditions for some object to be numerically one, just like one object and the particles that make it up, those are like kind conditions for individual objects, I think. So I think there's some good work there to be done as well. So here's how I conclude. The thesis from when I first started, given the dependence of many features of objects on social agents, boundaries, count, kind membership, etc., the social world may be much bigger than we thought. Some of those features are, at least in some way, partially dependent on us as social beings and the choices we make. And I think this creates new avenues and more work for the social ontologists, narrowing the gap between so-called traditional metaphysics, whatever that is, whatever we take it to be, and the field of social ontology. So rather than, or perhaps in addition to using models and categories from traditional metaphysics and applying them to the social world, it may prove more fruitful in some cases to use models and categories from the social world and social ontology and then apply those categories and models to traditional metaphysics or ontology more broadly. So my goal here was to demonstrate just a couple ways that that can be done. Thank you.